Hey everybody, so this is the solution video for Worksheet 10.5. We're going to be talking about how to graph trigonometric functions with transformations and such. So one thing we'll want to keep in mind anytime we do transformations of trig functions is remembering what the untransformed version of a sine or a cosine or a tangent looks like, and remembering key points like x-intercepts, maxes and mins, vertical asymptotes, things along those lines. We want to keep those in mind as important points. So let's get started with 1a. So we're going to graph one cycle. So we have to do one period of each of these, and we're going to want to state the period, amplitude, phase shift, and vertical shift for the function. Now I'm going to be referring to things like a, omega, phi, and b as part of the standard form for these functions. They're in the textbook, and they'll probably be in your notes, but I'll be referring to those values as we go through this process. So first, let's go through and identify the key values for this particular function, y equals 3 sine of x. So if we go through and we're going to identify our a. Now the a is the lead coefficient, which in this case is 3. Omega is going to be the coefficient of the x. In this case, omega is just 1. Phi is the number that's either being added or, well, it's the number being added to the x term inside the parentheses in the argument. And in this case, there is nothing, so we'll just put a 0 there. And then b represents the value that's being added to the entire function. In this case, it's not there either, so we just put a 0 there. So given these values, let's see how we interpret these for the characteristic amplitude, period, phase shift, and vertical shift. So the fact that our a is equal to 3 tells us that the amplitude, and amplitude is always the absolute value of whatever a is. In this case, it can be absolute value of positive 3, which would just be 3. So this has been vertically stretched by a factor of 3. Here, our period is defined as the period of the untransformed function, and for the sine, that's 2 pi, divided by whatever omega is, in this case 1. So here the period is unchanged, it remains 2 pi. The phase shift, in general, we define the phase shift as minus phi divided by omega. In this case, since phi is 0, the phase shift is 0, so there is no shifting going on. And with the vertical shift, this is what we get from the b. Since it's equal to 0, there is none. So we could say 0, or in both of these cases, we could just say none, and that'd be sufficient. Okay, so armed with this information, we're going to go ahead and we're going to graph this. So first, we'll bring up a set of axes. So this is the xy axis, and I think what might be helpful, you don't have to do this on your own, but as we make these transformations, let's consider what an untransformed sine of x function looks like. So I'm going to bring that up there. So this is just a regular old sine of x. The max and the min are positive and negative 1. The max occurs at x equals pi over 2. We have x-intercepts at 0 pi and 2 pi, and the min occurs at 3 pi over 2. So with this in mind, let's go ahead and get a sketch going on. So for this one, we will be able to retain, since the period has been unchanged, we'll be able to keep the key landmarks on here. So I'm just going to write over this. So we've got 2 pi, we've got 3 pi over 2, we've got pi, and then we've got pi over 2 as our key markers on the x-axis. Now the only thing that's really changed here, there's no shifting, so it's going to stay where it is. The only thing that's changed is the amplitude. So we're going to go up and we're going to raise the amplitude to 3 and negative 3. And all this means is that everything is going to get stretched a little bit vertically. So this max is going to now get stretched up here, and this min is going to get stretched down here. And if we just draw our curve now, we're just going to get the same kind of thing, except it's going to be much taller or amplified. And then we come back here. And of course this would continue infinitely in either direction, but we're only asked to graph one cycle here, and that would be the one we have there. So if we were to get rid of the original sine function, this is what we would have now as our transformed function. So it has a period of 2 pi, there's no phase shift, there's no vertical shift, and the amplitude has been raised to 3. Okay, so next let's move on to, we'll move on to part B. Okay, so I've already got the axes up there for this one. So for part B, we're going to go ahead and we're going to run through the same sort of process that we did with this last one. Is we'll identify the key characteristic values of our function, and then translate those into the actual physical characteristics of the curve. So we've got our a, in this case, is equal to 1. Here we have an omega that's equal to 3. That's the coefficient of x, and still we have no phi, and we have no b, so no vertical shift or no a phase shift. So an a equal to 1 implies that our amplitude is equal to the absolute value of 1, or just 1, which is normal for a sine or a cosine, so that means it's unchanged. Now the period is what's going to change here. So if we take the formula, so the normal period for sine is 2 pi, we're going to divide that by omega, which is 3, so our period is now going to be 2 pi over 3. And at this point I'm just going to abbreviate this PS. Our phase shift is none, we don't have one, and our vertical shift, which I'll abbreviate VS, there is none here either. So what is this curve going to look like? All right, well, let's start by bringing in a ghost of the original sine function. So this is just untransformed regular old sine of x. Now what we're going to want to do is we're going to want to change the period here. Now there's a couple different ways that we could do this, but one surefire way to get these key points is to just identify the key points, like the intercepts, the maxes, and the mins, and the asymptotes, and change each of them, and then we can plot them. So let's go ahead and consider doing that next. So let's say that to change the period, this is one way we could do it. We're going to divide all key points. So divide all key points by omega. So for example, the key points will be the intercepts, the maxes, and the mins for the sine. So we'll start with one of our x-intercepts. So the x-intercept of 0, we're going to take 0, divide that by 3. That's going to give us 0. So that's not going anywhere. So I'm just going to go ahead and I'm actually going to go ahead and plot that right now. So I'll put that point right there. The next thing that we would have is we would have our max. So our max occurred at pi over 2 on the unchanged curve, but we're going to go ahead and we're going to divide that by omega, and that's going to give us pi over 6. So pi over 6 is going to be right about here. 1/3 of the distance between 0 and pi over 2. So that means at this point will now be, since the amplitude hasn't changed, it's just going to be up here. And now we'll do another x-intercept. The other x-intercept that we had was pi, but now we're going to take that and we're going to divide that by omega. So that's just going to give us pi over 3. Pi over 3 is going to be sitting right here-ish. And yeah, so that'll be right there. So that's going to be our x-intercept. So we'll put a point there. And then our min, which was at 3 pi over 2. So we had a min at 3 pi over 2. We're going to divide that by omega 3, and that's going to give us, what, 3 pi over 6, which is just going to be pi over 2. So our minimum is actually going to occur at the pi over 2. So we're going to include that. So I'm just going to write over it so it stays, and then plot our minimum right under there. And then lastly, to get our full cycle, we're going to put in our other x-intercept, which was at 2 pi. and we're going to divide that by 3, and that just won't reduce any further. That's just 2 pi over 3. So 2 pi over 3 is going to be right here. And that's just going to be another x-intercept. Now notice that we've basically taken this interval from 0 to 2 pi over 3, which is our period, and it's been chopped up into little intervals of pi over 6. So in between each of these tick marks is pi over 6, and we could have gotten that by taking our period, 2 pi divided by 3, chopping it into quarters, and that would give us what we have. So when we play connect the dots, we get a curve that looks like this. So it's going to be really horizontally compressed here. Something like this. So you see a sine curve whose amplitude hasn't changed, it hasn't been shifted, but it has been horizontally compressed. The period has been reduced to 2 pi over 3. So if we were to actually to get rid of the ghost of, and I'm going to go ahead and fill this in. So 1 to negative 1 for our amplitude, and if we were to remove the sine curve, then this would be our transformed curve right here, and it has all the characteristics we would expect to see. Okay, so that takes care of that one. So now we'll move on to part C, which is negative 2 times the cosine of x. Okay, so we've got our axes set up, and we'll go through, and just like we did for the sine, we're going to identify all these key values. So our amplitude here, or excuse me, the A, is negative 2. So, and then our omega is 1, which we now know is going to mean it's unchanged. Phi, we still don't have any phase shifts, and we have no B. So that's going to be equal to 0. Now, one thing to note is that since that A is negative, this is going to mean we have an x-axis reflection. So that's something that we're going to want to keep in mind for later. That's because the A is negative. Now we're going to lose that once we figure out the amplitude, because to figure out the amplitude, we take the absolute value of A, and we just get positive 2. So if we didn't make note of that now, we may have forgotten to account for it later when we're graphing it. All right, so that's our amplitude. Our period remains unchanged. It's the regular period for the cosine, which is 2 pi divided by 1, so it's still 2 pi. And we have no phase shift, and we have no vertical shift. Okay, so let's bring up the cosine curve, just so we can kind of remind ourselves of this. So this is very much like the sine curve, except its maximum point starts on the y-axis as opposed to occurring at pi over 2 with the sine function. So this is just regular old cosine of x. Now let's go ahead and make the changes that we need to do for this one. So we would first want to change the amplitude to 2. So we're going to raise it from 1 all the way up to 2. And then down to negative 2. We're going to keep, since the period hasn't changed, we can keep all of our markers here. So pi over 2, pi, 3 pi over 2, and 2 pi. So all of those will stay there. Now, we're going to combine two transformations at once here. So this max point right here on our gray curve would go up to 2. But since we're reflecting across the x-axis, we're now going to drop it down to negative 2. So that's going to be our first point. It's been stretched vertically and then reflected across the x-axis. The x-intercepts are going to remain unchanged, so we'll put that there. The min, that was at pi, is going to get dropped down to negative 2 and then reflected across the x-axis up to positive 2. So there's our amplitude change and our x-axis reflection. And then the x-intercept is going to stay the same. And then just like our first point, this is going to get stretched up to 2, reflected across to negative 2. And then now, when we connect all of these points, we get something that looks like this. Sorry, I have a hard time talking and drawing these at the same time, so I'm just not going to talk. And that goes down there. All right, so that gives us one cycle or one wave of our transformed cosine curve. So if we removed the original just cosine of x curve, this is the transformed function, y equals -2 cosine of x that we would have had. Okay, so we had to combine a couple things in that one to make sure that we had the right curve. Okay, so part D. We're going to take cosine, and looks like we've got some other things going on inside here, so this will be a nice little change of pace. So we'll go through and we'll identify all of our key points. So our A, that's just 1. Our omega is also 1, the coefficient of x. Now we've got a phi. Now phi is the number that's being added onto x. So since it's minus pi over 2, we're going to write it as minus pi over 2. And we should know from 1.7 with transformations, when we start subtracting numbers within our function from x, that's going to give us a shift to the right. So we'll see that in a second. And then again, poor b is just left out of here, so that's going to be a 0. All right, so if we interpret these, our amplitude is the absolute value of 1, which is just 1. Our period is going to be the period for cosine divided by omega, which is 2 pi, unchanged. Now, phase shift. All right, so now we get to do something here. So phase shift, this is equal to minus phi divided by omega. So this is going to be minus pi over 2 divided by 1. So that's just going to be positive pi over 2, and we know that this is going to the right. So we're shifting everything to the right, pi over 2, or 90 degrees, along the x-axis. And poor b. Vertical shift. None. Okay, so now we're going to go ahead and put this together. So let's bring up our curve so we can see cosine. So this is normal cosine. And what we're going to do is we're going to shift all these points to the right, pi over 2. Now we can probably do this pretty easily visually on our own, but I'm going to kind of lay the groundwork for what we're going to need to do when it gets a little bit more complicated. So to shift our curve, actually, what we're going to do is we're going to want to take all of these points here, and we're going to, since we want to go to the right, we're going to add pi over 2 to all of our key points. So to shift the curve right, we're going to add pi over 2 to all points, namely the x-coordinates of all of these points. So we'll just use the key points. So for 0, we'll add pi over 2. That's going to give us pi over 2. And let's go ahead and start labeling this up. So the amplitude's unchanged. We got pi over 2. We've got pi. We've got 3 pi over 2. And we've got 2 pi. So this point right here, which was on the y-axis, is now going to get shifted over pi over 2 right here. And then the point that was at pi over 2, which was our x-intercept, if we add pi over 2 to that, that's going to go to pi. So the x-intercept gets shifted over here. So we're just taking all these points and literally shifting them over to the right, pi over 2. If we take pi and we add pi over 2, that's going to give us 3 pi divided by 2. So this min is going to get shifted over to 3 pi over 2. And then 3 pi over 2 plus pi over 2 is going to give us 2 pi. So this x-intercept gets shifted over to 2 pi. And then lastly, that last x-intercept, if we add pi over 2 to that, that's going to give us 5 pi divided by 2. So we're going to have to add another notch here. And this will be 5 pi divided by 2. And this will be this max that gets shifted up. So now we just kind of play connect the dots again, starting now at pi over 2. And this is what we get. So we can see that that gray curve has literally just been slid down the x-axis, pi over 2 for all points. And if we remove the that original one, that's what we get for this curve. So in general, we need to do those shifts. This is the thing we might want to do, is highlight the key points and then just add or subtract whatever the shift is, depending if we're going to the right or the left. Okay, so with that in mind, let's check out E. So we're going to take 2 times the sine of x plus pi over 6. All right, so if we identify all the key points or the key values, so A is 2, omega is 1, phi is positive pi over 6, that's what we're adding to x, and again, B is nothing. So from this, we see that our amplitude is going to be equal to the absolute value of 2, which is 2. So this can be vertically stretched, doubled, period. So the sines, since it's 1, the original period of the sine is unchanged, and we just get 2 pi. Our phase shift, we're going to take minus phi divided by omega, we get negative pi over 6. So this means that we're going to the left. When that phase shift comes out negative, it means you're going to the left. And then no vertical shift. Okay, so we've got to do a couple things here. So if we bring up, let's bring up this next layer. So I went ahead and I took an extra step here. So rather than just giving a ghost of the sine function, this is 2 times sine. So this is pretty easy for us to visualize. It's a sine curve whose amplitude has been increased to 2 already. So now the only thing that we really have to do is affect this this change of this shift. So first I'm going to go ahead and I'm going to put in these points. So our amplitude is from 2 to negative 2. And what we want to do now is we want to shift everything to the left pi over 6. So let's do what we did in the last one and identify key points. So to shift, we subtract, since we're going to the left, so subtract pi over 6 from all points. All right, so we have an x-intercept here at 0. So we're going to take 0 and we're going to subtract pi over 6, and that's going to be minus pi over 6. So this point is now going to go over to pi over 6 here, or minus pi over 6. So I'm going to label that. I'm going to put that point right there. And then this max that occurred at pi over 2, well, if we subtract pi over 6 from pi over 2, that's actually going to be what? 3 pi over 6 minus 1 pi over 6, which is 2 pi over 6, which is going to be pi over 3. So this point is now going to go to pi over 3. So our max, I'm just going to go ahead and I'm going to put that right there. So it's been shifted to the left, just a smidge. Now we've got our x-intercept, which was resting comfortably at pi. But if we subtract pi over 6 from it, that's going to give us 5 pi over 6. So we're going to move that over to 5 pi over 6 and plop that on the x-axis. And then we've had our min, which was at 3 pi over 2. And we're going to subtract pi over 6 from that. And if we do that, we're going to end up with 8 pi over 6, which is 4 pi over 3. And that's just going to be a little bit to the left of 3 pi over 2. So that's 4 pi divided by 3. And again, that's our min, so that's going to go down here. And then lastly, our other x-intercept, which was at 2 pi. If we subtract pi over 6 from that, that's going to give us, what, 11 pi divided by 6. So that's going to be right here, 11 pi over 6. And we'll plot that on the x-axis. So now we just take all of these shifted points and we connect them, and we should get our shifted and transformed curve. Okay, so you can see that these are almost the exact same wave, except they're slightly out of phase, thus the phase shift. And if we were to remove the... that's not what I wanted. Anyway, so that would be, that's what we'd end up with, our blue curve. Okay, so we've done lots with sine and cosine. Now we are going to, we're going to try the tangent function. So let's slide down and try the tangent. So first we'll go ahead and we'll draw our axes for this. Well, we can wait on that. Let's go ahead and analyze our values. Now, the thing that's going to change a little bit here is that since the tangent function normally goes up to positive and negative infinity, amplitude really doesn't apply. So we just think of that as a vertical stretch. So we'll still identify that lead coefficient, and that's going to be 1. So we're going to interpret this as no vertical stretch. Now the omega is 1. Now, so when we're trying, so that's the coefficient in front of x. So for period, we define period as the original period of the function divided by whatever omega is. Now the original period for tangent is just pi. So we take pi divided by 1, so our period is still pi. Our phi in this case is minus pi over 4. So our phase shift is going to be minus phi divided by omega, which is going to give us pi over 4. And since it's positive, it's going to go to the right. And then b, surprise, surprise, is 0. So we don't have a vertical shift. Okay, so now we're going to have to go ahead and sketch this up. All right, so first we'll bring up the axes. So there's our xy axis, and then let's take a look at what the regular tangent function would look like. So if we bring that in, we know that one cycle of the tangent goes, we've got vertical asymptotes at negative pi over 2 and positive pi over 2, and we have this one full cycle in between. So to do a shift, which is really all we have to do here, the period's unchanged, there's no vertical stretch, there's no vertical shift. All we have to do is do a phase shift of shifting all key points to the right, pi over 4, which is actually a little bit easier for us with the tangent, because we only have to shift 2 vertical asymptotes and then the 1 x-intercept to get one full cycle. So let's go ahead and do that. So to shift, what we're going to do is we're going to add pi over 4 to all points. But specifically for us, we're just going to use the key points. So the first one is our vertical asymptote, which is minus pi over 2. So we're going to add pi over 4 to that, and that's going to give us minus pi over 4. So this vertical asymptote has been shifted over to minus pi over 4. And then our x-intercept was at 0, but we're going to add pi over 4 to that, and that's just going to give us positive pi over 4. So that x-intercept is going to go over here to pi over 4. I'm going to plot that right there. And then our other vertical asymptote to complete one cycle was at pi over 2. We're going to add pi over 4 to that, and that's going to give us 3 pi over 4. So we're going to need to move that over here to 3 pi over 4. So we've got the 1x intercept and the two extremes for the vertical asymptote, so our curve would end up looking something like this. So that would be our transformed curve, and if we remove the other one, this is what we've got. So this would be our the transformed curve for the tangent of x minus pi over 4. Okay, so this is a doozy. All right, so we've got one more to go. So minus cosecant of x plus pi over 3. So we are going to take the exact same approach that we've done for all of these. And we're going to start by identifying the key points or key values. So our a, the lead coefficient is -1. So again, we're going to look at this and we're going to think this implies that we're going to have an x-axis reflection somewhere along the way. So our amplitude, and again, amplitude doesn't really work here, so I'm going to remove that because this curve goes up to positive negative infinity, so this is going to be no vertical stretch. Our omega is just 1, so the period of the cosecant is 2 pi, so the period is going to be 2 pi divided by our omega, which will just be 2 pi, so no change. Our phi is positive pi over 3. So this implies that we are going to have a phase shift. Our phase shift is going to be equal to minus phi divided by omega, which will be minus pi over 3. So this means that we're going to the left. So we're going to shift to the left pi over 3. And then, wow, totally neglected for this entire worksheet, but there is no vertical shift. Okay, so now we'll move on to actually graphing this. All right, so we really only have two things we got to worry about, which is the x-axis reflection and then the phase shift that we have to worry about. Let's bring in the cosecant. Now, in case you don't know how to graph the cosecant, or you forget what the cosecant or even the secant looks like for that matter, one thing to keep in mind is that I'm just going to write this up here. The cosecant of x is just the reciprocal of 1 over sine of x. So there's definitely a relation between there, and we can see this this way. So I'm going to graph just sine of x first. So this is a graph of just a regular old sine function. To get the cosecant, we're going to take every single one of those values and take the reciprocal of them. If we did that, we end up with something that looks like this. So the cosecant kind of just, we have these vertical asymptotes wherever there was an x-intercept on the sine, and then we get these little U-shaped things that go up to positive infinity or down to negative infinity. So this gray right here is the cosecant, the graph of the cosecant, but we can use the sine to kind of help us think about it. Okay, so now let's go ahead and shift. Let's do the shift first. So if we do the shift, we're used to kind of shifting these now. So to shift, what we're going to do is we are going to, in this case, we're going to go to the left, so we're going to subtract pi over 3 from all points. And if we do that, we'll start with now we're looking at the cosecant now, so we can kind of ignore the sine part here. So we've got a vertical asymptote for the cosecant at 0. So if we subtract pi over 3, that's going to give us negative pi over 3. So I'm going to go ahead and I'm going to put that on there. Keep those. minus pi over 3 is going to be something like this. So minus pi over 3. This is going to be sort of a vertical asymptote for our cosecant. All right, so next we've got on the cosecant curve, as we move along, we've got this min here of this u. So our min, which was at pi over 2, we're now going to subtract pi over 3. And if we do that, that's going to give us pi divided by 6. So this little min here is going to get shifted over to pi over 6. So we'll put that right there, tentatively. And then we're going to have another vertical asymptote. It was at pi. We're going to subtract pi over 3, and then that's going to give us, what, 2 pi over 3. So we're going to have another vertical asymptote there at 2 pi over 3. So 2 pi over 3. Just put that in there. And then we've got the max, which was at 3 pi over 2. We subtract pi over 3. That's going to give us 7 pi over 6. So that's going to be right here. And that would be this point. I'm going to sketch this in lightly because we still have to do an x-axis reflection over here. And then lastly, we've got one more vertical asymptote. So the last vertical asymptote was at 2 pi. If we subtract pi over 3, that's going to give us 5 pi over 3, which would be right here. So this is our remaining vertical asymptote. So the only thing we really have to worry about is this max and min. So this was a max right here at pi over 6. We're now going to reflect that across the x-axis and put it right there. And then this min, we're going to reflect across the x-axis at 7 pi over 6 and put it up here. So it's actually going to be a max now. And then just all we have to do is stay in between the lines for these vertical asymptotes, which is going to give us something like this. Now I know this is getting awfully busy, but I'll remove the other stuff in a second. So we've shifted it to the left, then reflected it across the x-axis. And as we remove all of these unnecessary things, we get something that looks like this. Okay, so that will do it for this worksheet. Hope that was a little bit helpful for you all, and I will see you all in the next video.